Hello, so here is our next recorded lecture. There we go. I'm trying to blow up our slides. And finally, there we go. So chapter 2 of the pharmaceutical calculations for pharmacy technicians. Chapter 2 is going to focus on Celsius and Fahrenheit temperature conversions. So the chapter 2 objectives are to convert between Celsius and Fahrenheit temperatures by the end of the chapter. You'll also be able to list common medication temperatures in the pharmacy and explain what the pharmacy technician is required to do concerning incorrect refrigerator and freezer temperatures. You'll also identify which vaccines must be frozen and not refrigerated. So Unit 1 is going to focus on temperature. Temperature measures sensible heat or cold. Normal human body temperature is 98.6 degrees Fahrenheit or 37 degrees Celsius. The most popular scales are Celsius scale created by Anders Celsius and the Fahrenheit scale created by Gabriel Fahrenheit. Temperatures are most often reported in Fahrenheit. The ratio of the difference between Fahrenheit and Celsius can be expressed as 180 is to 100. This is equivalent to 1.8 when it is reduced. Hence the formula. So we have two formulas here for converting between Celsius and Fahrenheit temperature scales. And I'm going to even show you a third formula in just a moment that can be used for either one. And we will leave it to you to determine if you prefer to learn two different formulas and work a little less math, or if you prefer to learn one formula that is going to entail a little bit more math. So these are the formulas to convert, again, between Fahrenheit and Celsius. The temperature to solve for Celsius, when we are provided the degrees Fahrenheit, is Celsius equals the degrees in Fahrenheit minus 32 divided by 1.8. If we are given the temperature in Celsius and we need to calculate the temperature in Fahrenheit, then we will multiply 1.8 times that temperature in Celsius and add 32. So they give us a knowledge check here saying that normal body temperature is 98.6 degrees Fahrenheit. What will the temperature be in degrees Celsius? So let's take a moment and peek at that. Okay, so here we go. We were asked to convert 98.6 degrees Fahrenheit into Celsius. So let's start with the formula that has been provided to us. You will notice I do have three formulas. This is our formula for solving for Celsius. This is the formula that we were given for solving for Fahrenheit. And this is the third formula that I mentioned I was going to share. This is what we call a universal formula. So it doesn't matter if we are solving for Fahrenheit or for Celsius. This formula works for both. And so I will show you how it works with both. So we're going to start over here, though, with the formula that we were given, which is going to be 98.6 minus 32 over 1.8. So if we plug that into a calculator, 98.6 minus 32 equals, I get 66.6. Divided by 1.8, I get that Celsius equals 37 degrees. So let me show you what that looks like on the universal formula. So I'm just going to drop down the 5F because I don't have the temperature in Fahrenheit yet. And I'm going to set that equal to, I'm sorry, I lied. We do have the temperature in Fahrenheit. I'm so sorry, y'all. So we're going to make that 5 times my temperature in Fahrenheit, 98.6. And I'm sorry if the writing's a little bit small for the video. And I'm going to set that equal to, I'm going to drop down the 9C plus 160 because I don't have the temperature in Fahrenheit. So the first thing I've got to do is eliminate this 160 hanging out here. And the way I'm going to do that is I'm going to have to subtract by 160 so I can isolate 9C over here on this side. And what we do to one side of the equal sign, we have to do to the other side of the equal sign. So let's go ahead and do our math. 5 times 98.6, which is 493, and we're going to subtract that 160. Leaves me with 333. And it is currently equal to the 9C. It is being multiplied to that C, so I need to divide to get rid of the 9 to isolate the C. And because I did that on one side of the equal sign, I have to do it to the other side of the equal sign. And so when I divide 333 by 9, I get the same answer I got over here. 37 degrees equals Celsius. So as you can see, not quite as extensive on the math with this formula, but this formula, there is a little more math. So again, it's going to go back to what's more comfortable for you. Do you want to learn 2 formulas and do a little less math? Or are you okay with the math being like this and just learning the 1 formula? It's going to be a matter of personal preference on that front. All right, so as you can see, when we do our knowledge check answer here, it came up with the same answer that we did. Normal body temperature is 98.6 degrees Fahrenheit. What will the temperature be in Celsius? And the correct answer is 37 degrees. So figure 2.1 here gives us a comparison of Celsius and Fahrenheit scales. So you can see that the boiling point at Celsius is 100 degrees, where in Fahrenheit it is 212 degrees. Human body temperature in Fahrenheit is 98.6 degrees, and Celsius, that is 37 degrees. Freezing is 32 degrees Fahrenheit and 0 degrees Celsius, just to name a few of the differences between the two. So here we have another example where we are being asked to convert 99.4 degrees Fahrenheit to Celsius. So they've already set it up for us with the formula for solving for Celsius. So they took the 99.4, subtracted the 32. That is where the 67.4 comes from. They have divided that by the 1.8 and determined that it was 37.4 degrees Celsius. And then they're telling us to use the following formula to convert a temperature from Celsius to Fahrenheit. So let's look at what that looks like. So here they're giving us 20 degrees Celsius that needs to be converted to Fahrenheit. So we were substituting the 20 for where degrees Celsius was in the conversion formula. So it becomes 1.8 times 20 plus 32. So 1.8 times 20 came to 36, plus 32 came to 68. So that converted from 20 degrees Celsius to 68 degrees Fahrenheit. They give you another method to convert from Fahrenheit to Celsius, and that is to subtract 32 from the Fahrenheit number, divide the result by 9, multiply the answer by 5. This is the universal formula, I do believe, but the way they're wording it is unique. So again, that formula was 5F is equal to 1.8C plus 160. So it's not quite the same formula, but they are using another formula here. So they subtracted 32 from the 95 degrees. It gave us 63. That result was divided by 9, which gives us 7, and then multiplied by 5, which gives us 35. So it's not really necessarily a formula, it's more of a step type way to achieve the same. Again, I'm going to say do what makes you comfortable. Are you comfortable following this example, or are you comfortable following one of the formulas? Me personally, I'm a formula girl. I prefer a formula. We are not going to do the think, pair, share. Common medication temperatures in pharmacy. So most of our over-the-counter and prescription medications can be stored at room temperature and will remain stable. Many medications can be maintained at temperatures as low as 52 degrees Fahrenheit or 11 degrees Celsius, such as the liquid forms of amoxicillin and interferon beta. No medications can be stored at temperatures above 86 degrees Fahrenheit or 36 degrees Celsius because they will become degraded. They're just getting too warm at that point. So we're given a knowledge check activity here. What is the lowest temperature that amoxicillin should be refrigerated at? Give you just a moment. And hopefully you came up with 52 degrees Fahrenheit or 11 degrees Celsius, because I just covered that in a PowerPoint slide or two back. Medication storage recommendations. Examples: Lipitor or atorvastatin calcium and Norvasc amlodipine bisabolate should be stored at room temperature, whereas Velatree or epoprostenol must be kept between 35.6 degrees Fahrenheit, that is 2 degrees Celsius, and 46.4 degrees Fahrenheit, or 8 degrees Celsius. We're given a table here, table 2.2-1 of common temperatures. Again, 212 in Fahrenheit is 100 in Celsius. That is the boiling point of water. There's our normal body temperature values, a very hot summer day values. There are your room temperature values, mild spring day values, warm winter day values, freezing point of water, and very cold wintry day. At what temperature will all medications become degraded? Hopefully you remember that was anything above 86 degrees Fahrenheit. That is what the PowerPoint had to say about that a couple of slides back. So I hope this has helped you out getting through chapter 2. Look forward to seeing you in the next video installment. Have a great day.